Hello class, welcome to the lesson 3.3. Remember that we are already in the stage 3 and now we're going to go over the lesson number 3, which is about fractional equations, a new concept, and extraneous solutions, which is also another concept for you to study. This word sounds a little weird, okay? So try to be aware of its pronunciation. It's more or less extraneous. Extraneous. You can look it up in Google, okay? Because the pronunciation is kind of hard. Okay, so we're gonna talk about these four concepts, guys. Number one, first I'm gonna give an explanation about the previous learning activity, okay? About something in the previous learning activity which dealt with literal equations that I want you to understand. I don't want you to have doubts. I don't want you to have doubts about this activity. Second thing, we're gonna define what are fractional equations. Number three, we're gonna talk about the domain of a fractional equation and extraneous solutions. What are these two things? And number four, as always, I'm going to give you several examples for you to be able to understand clearly how these equations are solved. So let's start. And hopefully everything is going to fit in here. So I'm not going to need to erase all of this. So let's start. So the first thing, guys, is I want to explain to you a little thing that I did not explain. I forgot to explain to you uh, something about the previous learning activity. If you go there, if you go to your solutions or the activity number 5, we're talking about learning activity number 5. I want you to observe, for example, the exercise C, which goes like this: Wx minus m equals 82. And then they tell you this, where W is different from 0 or different than 0. Okay, remember, what is this activity about? It's about isolating the variable x from all of these literal equations, from equation A to equation W. Okay, and in some of them you're gonna see something like this little phrase. What is this? What is up with this thing? Why did they tell me that I need to know that W cannot be 0 or it has to be different than 0? Why? Because of the following. If you noticed, in the process of the solution of this equation, let's do it, okay? What do we need to do? First, I observe this minus m, and I can add m in both sides of the equation, and my equation will become like this, okay? All I did was adding m. Perfect, nothing weird so far. The weird thing comes right now. If I want to isolate x, you must agree that the next step to perform is divide both sides over W, right? For example, this is the left side. I need to divide over W, and the same for the right side. That's what I'm doing, right? And then I can cancel, I can use the love cancellation. W cancels W, and finally I'm left with this. X equals 82 plus m over W. And everything seems perfect and nothing weird, etc., right? But there's a little nuance in here. There's a very detailed subtlety that you need to understand about what you just did, or in this case, about what I just did. If you notice, guys, we are dividing at this precise step, right at this step. What are we doing? We are dividing both sides of the equation over W, which is a variable, right? We don't know, we do not know the value of W at this point. Why? Because it's a variable. We don't know if it's 3, we don't know if it's minus 1 or 1/3. We don't know anything about W, okay? And remember that in mathematics, division by 0 is forbidden. You remember that? We can never divide anything over 0. That's prohibited. So how can I be sure that when I divide over W, in this case, since W can adopt many values, how do I know that I'm not dividing over 0? You see what I mean? We have to be sure that when I divide over W in here and over W, I need to be sure and establish, I need to make the supposition that W is not equal to 0, which is represented in this way. This is W equals 0. This is W is not equal to 0. I need to specify this from the start, guys, or maybe at this point, okay? When I'm about to perform such division, I need to say, hey, I need to tell my reader, hey, you know what? Just be aware that W cannot be 0 in order for me to be allowed to perform this division. Okay, I need to specify this. W is not equal to 0. I'm forbidding, I'm prohibiting W to be equal than 0. Okay, and then with that clarification, now I can perform the process very well. Okay, just knowing that W cannot be 0. And that's why the book let me erase this for I want clarity. That's why the book, guys, clarifies you from the beginning. Consider, you can read this in the following way. Consider that W is not equal to 0 in order for us not to have any problem in the remaining of the process. You see, that's what that statement, that little phrase where W is different than 0, that is the meaning of this phrase. Okay, so don't be scared or don't be confused. That's all it means. Okay, so that was an explanation that I needed to perform, guys, because like I've been telling you, I don't want you to have any doubt, or I want you to have as few doubts as possible in mathematics, because the rest of your knowledge in mathematics depends on previous knowledge, and everything has to be as clear as possible, as clear as water. Okay, guys, number 2. What are fractional equations? Okay, the definition is very simple, guys. A fractional, let me give you first some examples. A fractional equation is something like this. For example, this is a fractional equation, which I'm going to represent with FA, fractional equation for short. So this is a fractional equation. This is also a fractional equation. This is also a fractional equation, etc. Okay, what do you observe? By the way, this is a 4. What do you observe? Well, what you observe is that your variable, the variable in your equation, which in this case, in all of these 3 cases, is x. That variable, guys, appears in the denominator of your equation. You see? Look, the variable appears in the denominator. It can also appear in the numerator, no problem. But as long as your variable appears in the denominator at least once, then that classifies your equation as a fractional equation. Okay, so basically you have to remember that when the variable in your equation appears in the denominator, then we can classify such equation as a fractional equation. Even though it also appears in the numerator, that's okay. There is nothing wrong about that. But as soon as you see this, your variable in the denominator, then that's a fractional equation. And that's all it means. That's basically the definition. We don't have to write it down. We just have to understand what it is. And remember, I mean, as long as you can explain the concept in your own words, you don't need the precise definition, you know, like in the dictionary. No, I want you to understand. I don't want you to memorize things. Okay, so those are fractional equations. Now let's talk about the domain of a fractional equation and possible extraneous solutions. So what are these? For example, in a moment, guys, we're gonna try to solve this equation. Let me write it down right away. For example, we have this equation, 2x over x minus 3 minus 6 over x minus 3 equals 9. Okay, so in a moment we're going to try to solve this equation, and we're going to, well, do a process, right? A logical process of, operating simultaneously in both sides of the equation, the same operation, and so on, until we finally arrive, at some point, we finally arrive at the isolation of the variable, x equals something, okay? And we're gonna notice that for this variable, guys, the solution that we're gonna get is x equals 3. We're gonna get this as the solution, okay? And we may think, okay, I'm done. Okay, perfect. Let's go to the next equation. But there is something wrong about this supposed solution. Okay, what is the problem with this quote unquote solution? Well, the problem is that when you input such a value of your solution, okay, in quote marks, when you input this value into your original equation, what do you think you're gonna get? Is everything gonna be fine, or are we gonna be facing a problem? What do you think? Well, what's going to happen is the following. Let's do it. We're going to get 2 times 3, you see, over 3 minus 3, 3 minus 3, minus 6 over 3 minus 3 equals 9. I'm just substituting my supposed solution in my original equation, and I can see right away, guys, that we have a problem right here. How much is 3 minus 3? That's going to be 0, right? So basically, we're going to be dividing over 0. This over 0 and this over 0. And remember that that's not possible. So we are encountering a problem. What does that mean? That means that this supposed solution is in fact not a solution. This is what we know as an extraneous, this thing, x equals 3, it's going to be what we call extraneous solution. Okay, what is an extraneous solution? It is a solution that you obtain at the end of your process when you're trying to solve an equation, and that when you put it back in your original equation, your equation, let's say that it crashes, okay, or it exploits, or you find something that you cannot be done. Basically, it doesn't work. This solution will not work, and that's why we call it extraneous solution. And in general terms, guys, this means that this is not a solution, okay? It's not even a solution, because when you put it back in your original equation, the equation is not satisfied. So maybe this is extra, okay? It's not even a solution. It's not even a solution, but some people call it extraneous solution. So that's okay. That's one way to talk about this apparent solution, but it's basically not a solution. That's what it means. So basically, what you have to be aware of is that in this type of equations, fractional equations, when you arrive at your final solution and you go like, okay, I'm done, you have to prove that. You have to confirm that in fact your apparent solution is in fact a solution by going back and putting and substituting and making sure that it works. If it doesn't work, we have to label it as an extraneous solution. And that's basically what this concept means. You're going to see how it works in a moment. And what is a domain? What is this word? Well, what that means, guys, is the following. If you notice from the very beginning also of your equation, if I give you this equation and I tell you, okay, please solve it. All right, what you must notice first is the same thing I told you over here in this first explanation. If you notice, we have a variable in the denominator, okay? We have x minus 3 and x minus 3, and we must be aware of the fact that in order for this equation to be defined at all times, we cannot we cannot make this variable equal to 3, right? This variable is completely forbidden. It's forbidden to be 3. You see? Why? Because if we make x equals 3, we're going to get 3 minus 3 is 0, and we're going to be doing a division over 0, which is not possible. So from the beginning, we go okay, I'm sure about this fact. X cannot be equal to 3, okay? And we say this, x is not or is not equal to 3, okay? And we need to establish this, okay? And basically what we are saying is the following. If I want to use this word, I'm going to say the following. The domain of my equation, of my original equation, is all the real numbers, just like I told you before, this letter, all the real numbers, except 3. Okay, we say the following, guys. The domain of my equation is all the real numbers. Let me write this in a better way. There you go. The domain of my equation is all the real numbers except 3. What does that mean in simple terms? In simple terms, this phrase tells me you can give, let me erase this. You can give any number you want to x in this equation. I mean, in principle, right? In principle, x can have any value except 3, okay? The domain of my equation is all the real numbers except 3, because when x is 3, you're going to get a problem, a division over 0, and that's going to make the equation undefined. So that's what the domain is. It's basically all the set of numbers that are possible solutions to my equation, okay? And I'm only gonna exclude, you see this exception, I'm just excluding this number 3, because when I put the number 3 in here, my equation crashes, my equation begins to have problems. Let me give you another example. What if I give you this equation? For example, 1 over x plus 2 equals 5. I give you this equation and I tell you, please solve it. Okay, fine. You must be aware of the fact that the domain, first of all, the domain of this equation, let's write it down, the domain of my equation is all the real numbers except what number, guys? What number do we have to exclude from the domain so that this equation does not have problems of division over 0? What number I cannot give to the x, because if we do so, we're gonna get a 0 in here. Clearly it's gonna be minus 2, right? If I give x the value of minus 2, I'm gonna get minus 2 plus 2, which is 0, and my equation is gonna crash. So we say the following: the domain of my equation is all the real numbers except the number minus 2. I know from the start that this number cannot even be in my solution, okay? It's impossible. That's what it means, okay? Basically, you just, for the domain, you're gonna basically always write this this phrase: the domain of my equation is the real numbers except that particular number, or those particular numbers, because there may be more than one, that will produce a division over 0. That's basically what it means. One final example. What if I give you this other equation? 2 over x minus 3 equals 3 over x plus 1. Okay, is this a fractional equation? Yes, because my variable appears in the denominator. And what's going to be the domain? What are going to be those values that are going to produce divisions over 0? That's going to be the number 3, right? If I put the number 3 here, this is going to become 0. And if I put the number minus 1 in here, this is going to become 0. So we write the domain, I'm going to do it very quickly. The domain of my equation is all the real numbers except the number 3 and the number -1. We have to exclude these two numbers from the very beginning. And that's how the domain, that's how the idea behind the domain works. Okay, now let's go straight to the examples, guys. Okay. So let's start with the following example. Example number 1. We have this equation, x minus 5 over x plus 4 equals 7. Perfect. Okay, so what do we do? Okay, in order to solve a fractional equation, first get the domain. Let's write the domain. Domain. Okay, we're gonna write the domain of my equation is all the real numbers except, in this case, the number -4. Okay, this is the domain. All the real numbers except -4, because when I give -4 to the variable x, I'm gonna have problems in the denominator. Perfect. That's the first thing we do. And now we just start to solve the equation. Like I've shown you before, we're gonna do the same process, which is simultaneous operations in both sides of the equation, so that we eventually can get to the isolation of my variable. So the first suggestion that I'm gonna tell you to do is the following. Always try to get rid of denominators. Try to perform an operation in both sides, in this side and in this side, so that it will produce an equation without denominators. What can we do? Well, in this case, we can multiply both sides. This is my left side, and I'm going to multiply it by x plus 4. I'm going to multiply, there it is. I'm going to multiply by the denominator itself. When I observe a denominator, like, okay, this is a denominator, I'm going to multiply both sides of my equation by such denominator, because if we do so, you're going to notice that we're going to get a more manageable equation. Okay, so we have x plus 4 that multiplies this fraction, and so basically this cancels this factor cancels this factor, and that's why I did it, right? That's why I multiplied by x plus 4. And we're gonna get x minus 5 equals 7 times this. And let's multiply these two factors. We're gonna get 7x plus 28. Perfect. Let's continue. And now you can see that you get a more manageable equation, an easier equation than this one, right? Okay, let's continue. It's very simple from here. Let me subtract x from both sides. I'm gonna subtract x, and I'm doing it directly. You see, I'm not gonna write like, let me subtract x from both sides. No, let's just do it immediately. Once we understand what we're doing, we can do that, no problem. Okay, and then we have, look at this equation. What can we do next? We can subtract 28 from both sides, and I'm gonna get minus 33 on the left side after I subtract 28, and I'm gonna get 6x from the right side once I've subtracted 28. Perfect. Let's continue over here. Now let's divide both sides over 6. Again, let's do it directly once we understand the idea. Remember, we are not passing the 6 to the other side. We are dividing both sides over 6. And basically I'm done, right? Minus 33 over 6 is equal to x, so I'm done. X equals, let's simplify this fraction. You're gonna get, we divide over 3, we're gonna get minus 11 over 2. Is that right, guys? Yeah, right? Okay, so this is my solution. Now, how do I know it's a correct solution? I need to confirm. Remember, that is the problem with these equations, with fractional equations. You always have to go back to your original equation, always, and make sure that this solution checks, that this solution is in fact a proper solution. When you substitute minus 11 halves in here and in here, you're gonna get that all of this side is in fact equal to 7. I'm gonna leave that to you as an exercise. So this is in fact a real solution. Let's call it a real solution in order to say that it's not an extraneous solution, okay? So that's how it works. Okay, okay, I'm gonna erase the whole blackboard now. Now let's do another one. Example number 2. What about 3 over x plus 5 over 6 equals 1 over 4x? Okay, what is the domain of my equation? Let's write it. The domain of my equation, I mean, you don't have to do it this way, right? I'm not telling you that it has to be written with these precise words. Anything that resembles this is fine. The domain of my equation is all the real numbers except what number, guys? What number should I exclude from the domain of my equation? The number 1, the number 100. Which number, if I give it to the variable x, is going to produce a division over 0 in this equation? The number 0, right? Because if I give x the value of 0, I'm going to get 3 over 0, which is not possible to perform, and the same in here. Okay, so we have obtained the domain. Perfect. Now let's solve the equation. Okay, and remember what I told you. When you observe denominators in your equation, try to multiply by such denominators in order to get rid of them. So when I see this denominator x, I'm going to multiply first both sides by x. Okay, look at how I do it. I enclose my previous left side in parentheses and I multiply it by x. That's how it has to be done. A lot of people do this. They write the side like 3 over x plus 5 over 6, and they go like, okay, let me multiply this by x. Wrong. This is wrong. Or they write a little point here. They pretend that x is multiplying this side. This is wrong, guys. Why? Because if I don't put these two parentheses, okay, what I'm saying by writing only this is that x is multiplying only this fraction, but not this fraction. You need to enclose it like so. That is extremely important, guys. Okay, and so x multiplies my previous left side, and the same on the other side. X multiplies my previous right side. Okay, let's do it. X times this fraction, what do we get? We're gonna get 3 plus x times this fraction, we're gonna get 5x over 6, and x that multiplies this fraction, we're gonna get 1/4. I'm not gonna give you the details of why these multiplications give you these results. You should be able to understand why. If you want, make a little pause in the video and make sure. Perfect. Let's continue. So now we have these two denominators, 6 and 4. And you know, we can multiply first by 6, okay, both sides of the equation by 6, and then both sides of the equation by 4. Okay, that would be perfect, but it's going to be a little too long. So why don't we better multiply by the minimum, well, the least common multiple between 6 and 4. That's going to be a better idea. Let me write it down here. Multiply by the least common multiple. That's going to be a better idea, guys, because by multiplying by the least common multiple, I'm going to save one step, so to speak. So what is the least common multiple between 6 and 4? It's going to be 12, right? So let me multiply both sides by 12. I'm going to continue over here. So I write my previous left side. I'm going to multiply it by 12. And I'm going to do the same to the right side. I'm going to multiply it by 12. And let's see how that works. 12 times 3 is going to be 36. And then 12 times all of this fraction is going to give me 10x. One more time, I'm not going to give you the details. You can stop the video, no problem. I'm going to give you enough time for you to do that. And make sure that 12 times this will produce 10x. You're going to make sure of that. Equals 1/4 times 12, that's going to be equal to 3. You see? And now we have an equation, which is a very simple equation. It doesn't have denominators. It doesn't have your variable in the denominator, etc. So this is very simple to solve now. So let's do it very quickly. 10x equals minus 33. And finally, x equals minus 33 over 10. I'm doing these steps very quickly, okay? I'm not giving you explanations. And can we reduce this? No. It's going to stay like so. Minus 33 over 10. Now, you're going to pick this solution. You're going to pick it or take it. And you're going to plug it back in here. And you're going to confirm that it is in fact a solution. And let me tell you the secret, guys, right away. This solution that you get at the end will always be a solution, a real solution, as long, listen very carefully. If you want to write this down, write it down. As long as this solution is not the number that you excluded from the domain, okay? If you look at this and you go like, okay, my solution is not 0, then I'm sure that it will be a solution to my equation. Okay, that is the trick. You have to do that checking. You don't really have to confirm it by putting it in the equation, but that's enough for you to do this checking. If this number is not this number that you excluded from the domain, then this is a perfectly fine solution. Okay, and one last example. Let me see if I have time because I'm getting ahead of my schedule. Okay, let me give you this one, the one I told you at the beginning. Let's write 2x over x minus 3 minus 6 over x minus 3 equals 9. Okay, let's do this very quickly. What is the domain? The domain is the real numbers except 3. We cannot give x the value of 3. So we're done with the domain. Perfect. And now let's go down to the solution of the equation. We have this. Okay. And then if I notice that I have the same denominator in both fractions, well, I can go ahead and perform the subtraction, right? Like so. Perfect. And then we have this denominator equal to x minus 3. We're going to multiply both sides by this denominator. I'm going to do it directly now. You're going to get 2x minus 6 equals 9 times x minus 3. Let me continue over here. Then we're going to get 2x minus 6 equals 9x minus 27. Then we can subtract 2x from both sides. You see, I subtracted 2x, and then we can add 27. So when I add 27, we're gonna get 21 equals 7x. I added 27 here and 27 here, and I get this. And finally, we divide over 7 both sides. 21 over 7 equals x, and that tells me that x equals 3. And I'm supposedly done. Okay, this is my supposed solution. My supposed solution. What do I need to do next? I need to observe my solution, and I need to compare it with my domain. Look, the domain of my equation is all the real numbers except the number 3. What this phrase tells you is this. In principle, any number can be a solution of this equation except the number 3. That's what this phrase tells you. Any number is in principle a possible solution except the number 3. This number cannot be a solution to my equation, guys. And look at what we got. X equals 3. Okay, so that's why I'm writing this in quotation marks, because it's not a solution. It's not a solution according to my domain. If you take it and if you take this solution and you put it in your equation is going to explode. I've been pronouncing that word wrongly. It's not exploit, it's explode. Your equation is going to explode. It's going to crash because you're going to put 3 here and 3 there, and you're going to get divisions over 0. Can you see? So this is not a solution. This is what we know as an extraneous solution. And basically, we don't even consider it a real solution, so to speak. So what is my conclusion to this problem? My conclusion is that it doesn't have a solution, period. Okay, this problem cannot be solved. It's an unsolvable problem, like many in mathematics. Okay, guys, let me stop it right there. I think that was enough for you to understand the main concepts. Let's get on to work on the exercises. And if you have questions, as always, you ask me. Thank you so much, guys.